very good morning. Sit down. Okay, students. As per our last class, already you know about structure of atom and how electrons are arranged in cell and subcell. It is cleared by Bohr atomic model. You know clearly, nucleus is in the center and electron moves in the circular orbit or a fixed circular orbit. So now there is a question in our mind. If hydrogen have 1 electron, carbon 6 electron, calcium 20 electrons, zinc 30 electrons, obviously there is a question. Suppose you have only one book, then your arrangement style is different. Suppose you have 10 books, then arrangement style is different. Suppose you have 30 or 50 books, then your style is different. And when you go to a library, that is different. Obviously, yes or no? So compare this in the elements. Hydrogen have 1 electron, carbon have 6 electrons, calcium have 20 electrons, zinc have 30 electrons. Obviously there is a question, is the arrangement style is same? Obviously no, obviously it may differ. How they arranged or how electrons arranged? As you know previously, quantum numbers. What is the topic? Quantum numbers. Previously you know that quantum numbers are set of 4 numbers which address to the electron. That means first one is n, principal quantum number, k, l, m, n. Second one is azimuthal quantum number, s, p, d, f, and magnetic quantum number and spin quantum number. Now actually the electrons are arranged in the subcell, that is SPDF. These are subcells. From Bohr model, it is also clear that K, L, M, N are cells. Then in quantum number, we know that azimuthal quantum number SPDF are subcells. So actually the electrons are arranged in the SPDF subcells, which is called electronic configuration. As we arrange in the book, we arrange our books in a shelf or a rank or in a almirah, or you go to a library, there are mentioned this is chemistry, means all books are chemistry. This is physics, means all books are physics. Like this, if we arrange the electrons, 1 electron or maybe 30 electron, then it is called electronic configuration. Now come to the topic electronic configuration. Electronic configuration. What is electronic configuration? The arrangement of electrons in the subcell, that is S, P, D, F. That is S, P, D, F. This is called electronic configuration. Now, how electrons are arranged in the subcell? There is a rule. Bohr principle. According to this principle, the orbitals are filled or electrons are filled as the increasing order of their energy. The energy is represented by n plus L formula. Okay. Suppose 1s. In 1s, n plus L value is, that is 1 and 0. Why? SPDF value is 0, 1, 2, 3, and value of KLMN is KLMN. It is 1, 2, 3, and 4. You know previously in the quantum number, already you know about this. Now for 1s, energy level is 1. For 2s, energy level is 2 plus 1, that is 2. For 1s, 2s, 2p, energy level is 2 plus 1, that is 3. So the energy level increases. In which order? Sorry, it is 0. Good. It is 0. S is 0. So in this way, energy level increases. If we arrange it, then our order is 1s, 2s, 2p, 3s. Good. Then good. 4s, 3d, 4p, like this. So what is electronic configuration? Electronic configuration is arrangement of electrons in these subcells. Remember it. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. If you arrange the electrons in this order, it is called electronic configuration. Okay? No doubt. Remember this one. 1s, 2s, 2p, 3s, 3p, 4s, 3d. How it arranged? It arranged due to as per increasing order of the energy. Increasing order of the energy. Formula is n plus L. Next, another one important rule is Hund's rule. Hund's rule say that no pairing of electron takes place unless each orbital is filled by single electron. Again, in quantum number, you know S, that is 1 orbital, S subcell 1 orbital, P subcell how many orbitals? 3 orbitals, D subcell how many orbitals? 5 orbitals, and F subcell how many orbitals? 7 orbitals. 1, 2, 3, 4, 5, 6, and 7. These are SPDF, these are subcells, and these are number of orbitals. Number of orbitals. Now say, what is the number of electron in a orbital? In a orbital, there are maximum 2 electron. In orbital, maximum 2 electrons. But Hund's rule say that no pairing of electron takes place. No pairing. No pairing of electron takes place until each orbital is filled by single electron. What is this rule? This rule said that first you have to fill single electron. Suppose I say that is 4f6. 4f6. Then how to fill? First 1, 2, 3, 4, 5, 6. First fill single electron. Not like this. Means there are 7 orbitals. 1, 2, 3, 4, 5, 6, 7. There are 6 electrons. Means this one, and this one. Remember carefully. If you make like this, it is your right, it is your wrong. Understand? What is Hund's rule? This is right. Means first you have to fill each orbital by a single electron. 1, 2 single. If you first make coupling of electron, that is double, it is wrong. Okay? Understand the principles? Now come to our topic, electronic configuration. Suppose electronic configuration of calcium. What is number of calcium? Atomic number of calcium? 20. That means calcium have 20 electrons. Now electronic configuration means we have to arrange the 20 electrons in the subcells. What are subcells? 1s, 2s, 2p in that order. Now arrange. First 1s. How many electrons are in there? 2. We have total number of electrons? 20. Then 2s. Again 2. 2p 6. 3s 2. 3p 6. 4s 2. Total number is 20. We have 20 electrons. That means it is electronic configuration of calcium. Now say that scandium. This is scandium plus 1. Suppose scandium plus 1. What is number of scandium? 21. Scandium is 21. Scandium is 21. But plus 1 means, you know, plus means loss of electron, minus means gain of electron. Here in Sc there is plus 1 charge, that means it lost 1 electron. So 20 minus 1, that is 20. 21 minus 21 minus 1, that is number of electron is 20. Now say electronic configuration of scandium plus 1 is equal to electronic configuration of calcium. When there are two same number of electrons of two species, these are called isoelectronics. Isoelectronic species. These are called isoelectronic species. That is calcium and scandium plus 1. These are isoelectronic species. What are isoelectronic species? Two atoms or elements or species or ion. It may be atom, it may be ion, which have same number of electron. That is isoelectronic species. Okay. Now the important electronic configuration is, suppose copper. What is number of copper? 29. If you consider electronic configuration of copper, then I can write 1s, 2s, 2p, 3s, 3p, 4s, 3d, 9. Like this. But important formula of electronic configuration. What is the important point? Half filled and full filled orbitals are, half filled and full filled orbitals are more stable. Listen carefully. Whenever you consider a half filled or full filled orbitals, these are more stable. S orbital lower energy level, p orbital little more higher energy level, but d orbital is higher energy level. And if d orbital have 5 electrons, it is half filled. If d orbital have 10 electrons, it is full filled. Yes or no? Understand clearly? If d orbital contain 5 electrons, it is half filled. If d orbital contain 10 electrons, it is full filled. So we conclude that d always try to keep 5 electrons or 10 electrons in the outermost orbit, if it possible, not in every condition, if it possible. Now in this condition, d orbital will try to keep 10 electrons because it have 9 electrons. It try to keep 10 electrons in the outermost orbit. How it become 10? The nearest orbital is s. So it try to take 1 electron from s, and in the 4s 2 is fulfilled, 1 is half filled. That's okay. देखो, electronic configuration of copper is like this, but this is actually not correct. Why? Half filled and full filled orbitals are more stable. If you have question to write the electronic configuration of copper, then you have to write all these are right. Up to this, it is right. These two, you have to write 4s1 and a 3d10. This is right. Understand clearly? For electronic configuration of copper, that is not 4s2 and 3d9. It is 4s1 and 3d10. Why? Rule said that half filled and full filled orbitals are more stable at their configuration. Okay. Now my question, write one electronic configuration. I will see your copy. Write electronic configuration of chromium. Write in your copy electronic configuration of chromium. Write what will be the electronic configuration of chromium. As you know, chromium. Okay, fine. First say what is atomic number of chromium? 24. That means chromium have 24 number of electrons. Now arrange in this way. Arrange. Show your copy. 1s, 2s, 2p, 3s, 3p, 4s, 1, 3d5. Good. Actually it is 4s, 2, 3d4. But as per half filled and full filled orbitals are more stable, it will 4s1 and 3d5. Write it clearly. Good. 4s1. From you, we have not completed yet. What is the problem? 1s, 2s, 2p. Okay. You? No, this is not like. 4s, 1s, 2s, 2p, 3s, 3p. Then what is the next orbital after 3s? After 3s, next orbital is 4s. Just keep it. After 4s, next orbital is 3d. Just similarly, it is 4s2 and 3d4. But think, 3d4 is near about 3d5. So it will become 3d5 and it is 3d4s1. Clear now? Okay. Okay. All of you clear about it? And now, today's homework. Write electronic configuration of Ca2 plus Cl minus K plus Fe2 plus and Zn plus. Today's homework is you have to write the electronic configuration of this species. I have given all are in ionic species. You have to just follow the rule. If loss of electron, that is plus. If gain of electron, that is minus. Okay. This is all about your electronic configuration. Next class we will again revise it and do the exercise. Okay. Good.